So if I compress this spring with this block, and now if I release it, the spring is able to do work on the block. How can it do work? Because of its compressed configuration. So it has compressed configuration. Potential energy is energy.
So the one is to the internal spotlight. Sound. Hello, can you hear us?
Yes.
Yes, we can.
Yes, we can.
Tell your
Yes,
friends.
we can.
Well,
Even saying, eh?
I'm going to go.
Yeah, we can see.
Yes.
Matter and energy. Is energy exciting? Absolutely. Because there are so many different forms of energy all around.
Oh my gosh.
Hello?
Yes.
Can you hear me?
Yes.
Yes.
Just testing the sounds to see whether.
Around us. In this video, I'll be talking about the different.
Okay, people mute yourselves and so that you can hear the video. I don't want to mute you for good. Mute yourselves. Seems people, they don't know how to mute yourselves. Let me mute you for good.
The entire universe is made of two things, matter and energy. Is energy exciting? Absolutely, because there are so many different forms of energy all around us. In this video, I'll be talking about the different forms of energy, and then we'll do the top 3 exam-oriented questions on this topic. You might have heard of these different forms of energy, such as potential energy, kinetic energy, heat energy, chemical energy, light energy, sound energy, electrical energy. I mean, the list is endless. But we'll be discussing some of these important energy forms in detail in this video. What is potential energy? Let's take a look with a couple of examples. If I lift this hammer to a height, it has energy stored in it. That's called potential energy. Because if I release this hammer, it can do work on the nail. So it has this potential energy due to its position. Let's take a look at another example. So if I compress this spring with this block, and now if I release it, the spring is able to do work on the block. How can it do work? Because of its compressed configuration. So it has potential energy due to its compressed configuration. Potential energy is energy due to a height or due to its configuration. Let's put potential energy on our concept board. Potential energy is due to position or configuration. Next, we have kinetic energy. So what is the difference between a stationary ball and a moving ball? So the object is the same. The difference is a moving ball possesses kinetic energy. Kinetic energy is the energy in motion. So when you're running or you're walking, you have kinetic energy. A moving car has kinetic energy. So what do you think about a flying bird? So since it's flying, it has kinetic energy, but the bird is also at a height. So it's got potential energy as well. And this sum of kinetic and potential energy is known as mechanical energy. Let's stick kinetic energy onto our concept board. Kinetic energy is for motion.
Grammarly does more than catch errors. With Grammarly, you can find really good, no.
What is the difference between a glass of cold water and a glass of hot water? Ouch! The glass of hot water has more heat energy than the glass of cold water. Similarly, when you burn something like wood or a fuel like petrol or diesel, it gives out heat energy. Heat energy is usually measured in calories. So do you know how do we define 1 calorie of heat energy? It is the amount of heat energy that you need to add to 1 gram of water to increase its temperature by 1 degree centigrade. And 1 calorie is 4.2 joules, where joule is the SI unit of energy. Now let's place heat energy on our concept board. Heat energy is associated with how hot an object is. Chemical energy is the energy stored in a substance that is released through a chemical reaction. Now, what are some examples of chemical energy? Fuels are good examples. Fuels like coal, petrol, diesel. And we know that burning is a chemical reaction. So when these fuels burn, they release out energy in the form of heat and light energy. The food that you eat gives you energy. So what form of energy is food? The food is like a fuel to our bodies. So it is also considered as chemical energy. I know it doesn't sound good, but in the end, we are eating chemicals. The energy of food is measured in calories. Earlier in this video, we saw that heat energy is also measured in calories. But be careful, this is a common confusion because the calories of heat and calories of food are not the same. The heat calorie we wrote with a small c, but if you noticed, when we are talking about food calories, we are using a capital C. The heat calorie is a very small amount of energy. The energy needed to raise 1 gram of water by 1 degree centigrade. But food calories is much bigger than this. In fact, 1 food calorie is 1000 calories. And so it's often written as kilocalories or kcal for short. Let me go ahead and show you. So do you know how much energy you get when you drink this pack of juice? So you can find that out by looking at the product information here. So as you can see, this 200 ml juice contains 50 kcal of energy. So that's 50 kilocalories of energy in this pack of juice. Now, do you know how much calories are there in a banana? It's about 100 calories of chemical energy. A cup of milk contains about 150 calories of energy. And a bowl of rice is 200 calories. Do you know how much an average teenager needs per day? It's about 2000 calories of energy per day. And remember, when I say calories, I'm talking about food calories, so it'll be 2000 kilocalories of energy per day. Now let's pin chemical energy on our concept board. Chemical energy is linked to fuel or food. Light energy. What are sources of light energy? The sun, bulbs, LED lights, candles, these all give out light energy. Light energy helps us to see the world around us. If there was no light, then our discussion would look something like this. Now, we don't want that, right? Lights on. Let's stick light energy to our concept board. Light energy helps us see. What is the energy that helps you hear this video? That's right, it's sound energy. So when we are speaking, we are producing sound energy. A music system produces sound energy. If you touch the speakers, you can easily feel the vibrations, especially if the music is a bit loud. Similarly, while speaking, if you put your hand here on your neck, you can easily feel the vibrations. Sound energy is produced by vibrations. Now, if there was no sound energy, then our discussion would sound something like this. We don't want that, right? So let's get the sound energy back and let's move on with our discussion. Let's put sound energy onto our concept board. Sound energy enables us to hear.
Monster Math presents Addition Below 10. Okay, class, let's begin.
Today, our daily lives are highly dependent on electrical energy. If you look around you, you can see that the lights, fans, TVs, refrigerator, computer, everything is running on electrical energy. So how do we get this electrical energy? It's coming from the power station to our homes through these long electric cables. And when you get the electric bill at the end of the month, do you know what are you paying for? You're paying for the amount of electrical energy that you consumed that month. So if you want to reduce your electricity bill, do remember to turn off your lights and fans when you're not using them, and then you'll save on your bill. Let's put electrical energy onto our concept board. Electrical energy can be obtained from the plugs in our house or by using a battery. So here is a summary of all the energy forms that we have looked at in this video. I would encourage you to pause here and note down this summary. Now that we have looked at all these different forms of energy, let's move on to our top 3 questions on this topic. Question 1. I'm going to do some things here and you need to be a science detective and identify all the forms of energy that you see here. As a recap, let's look at all the forms of energy that we have learned in this video. Okay, detective, are you ready to identify the different forms of energy? Here it goes. I'll play it one more time for you. Here it goes. So how many different forms of energy did you get? Let's analyze the video. I'm switching on this lamp. What form of energy is supplied to the lamp? It's electrical energy, supplied through the wire here. When the lamp is on, what form of energy is the bulb giving out? Light and heat energy. When I lift this ball to a height, the ball has potential energy. As it falls down, it gains speed. So the ball has kinetic energy. When it bounces back to a height, the ball has potential energy. When the ball is somewhere in the middle, as shown here, it has both height and speed. So the ball has both potential and kinetic energy. And this sum of potential and kinetic energy is called mechanical energy. Do you hear the ball bouncing? So that's sound energy. I am drinking this juice. Juice or food is chemical energy. So all these forms of energy are present in these simple things that we use in our everyday lives. So all the forms of energy that we have learned are present in this question. Question 2. What is the energy of a flying aeroplane? Hint, it can be more than one form of energy. So to help you choose, let's go ahead and pull up our concept board. The answer for a flying aeroplane is potential energy and kinetic energy. An aeroplane is at a height, so it has potential energy. Since it is flying, it is in motion, so it also has kinetic energy. We can also say that the aeroplane has mechanical energy, since mechanical energy is the sum of potential and kinetic energy. Question 3. What form of energy is stored in a cell or a battery? I'm sure all of you have used a cell or a battery in toys or torches. What happens when the battery becomes really old and you don't replace it? It can leak. The chemicals inside the battery, they start leaking out. Since the battery is made of chemicals, the energy is stored in the form of chemical energy. When the battery is being used, a chemical reaction is taking place inside the battery and it supplies electrical energy. In summary, the battery stores chemical energy and supplies electrical energy. So next time when you look around you, I would encourage you to put on your thinking glasses and look for the different forms of energy around you. I'm sure you'll be able to identify them because energy is present everywhere. It's just in all these interesting different forms. And do remember to like, comment, and share this video, and also subscribe to my channel. Now I'm feeling tired. I need to grab some food. Oh, sorry, some chemical energy. So off I go. Thanks for watching.
Oh,
It's Junior's anniversary. We are celebrating with offers and freebies you won't want to miss. Junior,
right.
every make delivered.
Good morning once again. Good morning, students. Can you hear me? Anyone who can hear me? Aliyah, should I do roll call first? Shanice, why can't you speak up? Hey, I blocked you. Lava. I muted each one of you.
So we can hear you.
Good morning. We can hear you. Yeah, you muted us.
Muted us.
Yeah, you have some nerve muted us.
We're supposed to be
You are busy replying.
We were trying to reply to you, Kumbe, we couldn't even hear.
Miss Teacher.
Hi, people.
Hello.
Amina.
Hello. Nice day. Please to say.
Wonder they mute. Which Elaine is that?
Like,
What's up, no?
The one informed me.
Things are good.
Please.
Okay.
As in Elaine.
Let's now get back to the lesson. Actually, we have had a very good preamble of what we are supposed to cover. Mr. Sender would have told me we have been doing work, energy, and power. You have discussed work, you have discussed power, and now we are supposed to discuss energy. But that man, that Indian has even done it all, I guess.
Teacher, we did some exercise.
Come again?
We did some exercise. We need correction.
Or why you need marking first? Marking first.
Even
Why
correction.
The numbers was so hard.
Numbers was so hard.
For example, which one? One person to read for me that number.
Number 2.
Number 2 is
A ball of 1 kilogram bounces.
Who is reading to us? Condoleza.
A
Condoleza.
ball of 1 kilogram.
Like this, huh?
Ball. Bounces off the ground. To a height of 5 meters. Find the energy loss.
Very good. Now, that's energy. Under energy, we shall also talk about what we call energy conservation law. You mentioned that one earlier? No. Very good. So let's first discuss Reina Hirose. I hope I've read it well. Your hand up. What do you have to say before we continue?
Teacher, I can help. Oh my God. Explain.
Yeah, you can help explain, but your network seems not to be very good, so we may not really make use of your explanation. I don't know. Maybe later when your network stabilizes, we shall call you upon. Huh?
Okay.
Okay. But I should spotlight issues of people who want to. It is there. Good. So we have in the video we watched about energy. Can we keep review what we that video? We shall come back to this question, don't worry. Energy. Can we define energy? You know what define energy?
Energy is the ability to do work.
Every time you have the ability to work, it means you have energy. And it is not only human beings that can do energy. For example,
What about the number?
I said we are going to use the idea of energy conservation law to do that number. And therefore, we want to have what the energy conservation law is all about first. Then we can use that concept to do that number. Is it okay?
Yes.
So we shall come back to that number. But for now, let's first talk about this. It will give us the way of doing that. So, ability to do work was saying in the video, this gentleman showing us, actually he demonstrated something. He held a ball, a hammer, and was hitting a nail. For those who are there at the beginning of the video. And we said when you get the hammer very nearby, you hit the nail, it can only move a small distance into the wood, for example. When you lift it and get a higher point and then you hammer the nail, it will move a bigger distance, meaning you have done more work than when you get it from nearby. So the idea he was talking about energy. So what work am I talking about? The work is not about just lifting a jerrycan of water and reach home and think you have done work. Anyway, you have done work, but there are many ways of doing work. Okay? Your work, we are give us examples of work that can be done. Probably I don't have to be the only source of information. Can you cite some examples of work that can be done? I've given an example of hammering a nail, having a nail get into.
Lifting a jerry can, like a 20-liter jerry can.
My name. Okay. My network seems poor, it's like I'm frozen.
No.
I'm back. I was saying, can we cite out some examples of work that can be done? I also have some people here in class, so they can also give us answers.
Walking upstairs.
Someone saying walking upstairs, and another one here is saying when digging, you are doing some work. One example when digging is that you are lifting the hole up. That's already doing some work, right? Let me work on my internet as if it is.
When speaking. Hello. How are you? Hello.
My network.
Hello.
Am I still freezing that side?
No.
Continue.
No.
We are giving examples of doing work. Someone said when digging, someone said when speaking. Very true, you are doing work when you are speaking. Writing, you are doing.
Pushing a trolley.
Jogging.
Jumping a rope.
Carrying a bag of cement upstairs.
When it's
Carrying a bucket.
I was waiting for that. How
Jogging.
Eating.
Good. So let's look at the examples.
jumping
Now,
a rope.
jumping a rope. Have you ever even? Some of you can't jump even 2 centimeters in space. That is okay. That's good. So ability to do work, we have seen even the work we can do. Now, in the video, we talked about forms of energy. Forms of energy. We are going to go very fast because we already saw this one. The video was a bit clear. It was explaining everything. So can we just cite some examples of
Potential energy.
Excuse me, teacher.
Kinetic,
Electrical
We are not
energy,
seeing
Excuse
the board.
sound energy,
heat
teacher.
energy,
Light
magnetic energy,
sound energy,
air
okay.
energy.
So we are not seeing the board.
I'm going to change. But I would not wish to mute you again. Let us just be orderly and high by showing hands so that we are organized. For example, Akampa, when you say something.
Chemical energy.
Where I should be stopping, right? Good. So we are looking at forms of energy. Someone had already mentioned potential energy. Akamba?
Chemical energy.
Please, can you enable your chat?
Shakira? Shakira, what's your answer?
Light energy.
It's energy. Yeah.
kinetic energy,
Energy. Victoria,
Electrical energy.
you have mentioned what other students have mentioned. Yeah, you have got
Nuclear energy.
electrical, nuclear. Lisa.
Sound energy.
Come again.
Energy. Sound energy. Sound energy.
Sound energy. Curiosity.
Light energy.
Goretti.
Radiation energy.
Radiation energy. Radiation energy. Let me get that from here. Maybe we shall talk about the sources. Now we can talk about the geo, the one from
Geothermal energy.
Geothermal energy is geothermal energy. We can categorize it under heat energy, but probably when we talk about sources of heat energy, now geo becomes one of the sources. That is energy from rocks. So it is under heat energy. Thank you.
mechanical energy,
Mechanical energy. Mechanical energy, later we can see that when we combine potential and the magnetic, this and this, yes. That's what we call mechanical. Let me get one answer from here. Okay. Anyone else, Victoria?
Magnetic energy. Magnetic energy.
Magnetic.
Magnetic.
It's also magnetic.
Yes.
This one. What does it? Okay, magnetic energy. Ayebare, Alicia.
Solar energy.
Solar energy.
Teacher, shouldn't we put solar under heat?
And light.
Solar energy.
Yes.
Maybe unless we run under electricity. But solar energy is independent. Eh? We shall see the sources of each one of these ones, then we shall see the difference. Rose, Mary, all these names are yours. Mary, Rose,
Wind
Zala,
energy.
Kagenda.
Wind energy.
Any others? Here you have a new one, another one.
Teacher.
Mm-hmm.
Teacher, what about elastic energy?
Come again?
What about elastic energy?
Elastic energy. Elastic energy, we shall put it under potential. I will explain. I think these are some. Can we quickly recite what we know about any of these ones? About what we know about them is either you can be knowing the source or how it comes about. Okay, quickly, potential energy. Or you could even be having a different number of energy. What do you know about potential energy?
It occurs due to position.
It is the energy possessed by a body at rest.
Energy possessed by rest. That is, someone is calling it inertia. Okay, we have had that one. Any other person with something about potential energy?
It occurs due to position and configuration.
Occurs due to position and configuration of a body.
Teacher, when an object has a height, it's in potential energy.
Teacher. A body raised above the ground has gravitational potential energy equal to the work done against gravity.
So we are saying, I think all of us have the idea that there is what we call gravitational. Is it also freezing that side?
Yes.
Yes.
We'll stabilize, don't worry. Not wrong with my network today. No, someone has looked at my file with a bad eye. Especially this one here, this one. And back. Possess. Oh, outside.
My lord.
Let's see. Should I change or not my file? And this network is making me look like a ghost. Right, I guess we are back.
Yes.
The network was making me look like a ghost. Can you imagine?
Watch the Gedot, yeah.
Yes.
Now, the gravitational potential energy is energy possessed by a body by virtue of its position in the gravitational field. Someone to give me the spelling of possessed. Not possessed as in having. Is it the Holy Ghost? Possessed, what's the spelling? Double S?
Yeah.
Yes.
From here on.
Yes.
Double S again or single? Possessed.
Yes.
Okay. Then someone said that gravity. Who was that one who mentioned something to that? Maybe Regina, you mute.
Me.
Yes.
Regina, you mute. Huh? We don't want to force you to mute. But you have not muted. Good. So what we are saying here is, someone said that it is the work done against gravitation. Now, when you are looking at work done, you say work done is force times distance. You remember?
Yes.
You said, now, gravity will always act to pull you. Gravity will always act to pull you to go towards the center of the earth. Probably one thing we need to know here is that if this one is the earth, we actually live on the earth, not in the earth. Wherever you are on top here. Whether you are here or someone is here. We are all on the earth, not in the earth. And therefore, gravity will always pull you to come towards the center. If this is the center of the earth, gravity always pulls you to come towards the center. And that's why you cannot fall off, because there is a force that keeps pulling you towards here. So you can't fall off the earth. You will wonder who is here and who is here. You may think you are the one, actually the ones here. There are even others who are here. What is keeping them there is gravity. It is pulling them towards the center of the earth. So what do I mean, or what do I want in this? That this gravity keeps pulling you towards the center of the earth. That means, even if you have something here in space, supposing this is a stone, like you can throw a stone in space like this. I'm having this chalk. When it is here, the gravity is pulling it towards the center of the earth. And that force it is using is actually what we call the weight. Weight of a body. Your weight is actually the gravitational force that is acting on you, pulling you towards the earth. That force that acts on you to pull you towards the earth by gravity is what we call your weight. And we get weight as being your mass times acceleration due to
gravity.
What we call energy. That means if we are doing any work against gravity, the force we are using is actually our weight. Okay? And this gravity, since it acts vertically downwards, then when we are working against gravity, it means we are moving above, we are moving in a vertical direction. In such a case, in our formula where we talk of work is force times distance, the force will be written as our weight, which is mg, and the distance can better be expressed as a height other than horizontal distance. And therefore, in the formula for work, we write F as mg, which is our weight, and the D is written as h because we are talking in terms of height, because gravity acts in terms of height, or vertically downwards or vertically upwards. Therefore, if we are talking about work done against gravity, we are going to call it potential energy, because we have said potential energy is work done against gravity, so the work will now be called potential energy. Since it is gravity, the force we use is the gravitational force on that body, which we said is actually the weight of that body. Therefore, instead of writing F, we shall write the weight of that body, which is mass times gravity. Then the distance, whenever we are dealing with gravity, the distance we are talking in terms of vertical motion. Either you are going vertically upwards or you are moving vertically downwards. So the distance can better be talked about as height. And therefore, instead of writing D, we write it as H. And therefore, the formula for potential energy is given by mass times acceleration due to gravity times the height. Are we together? Have we known how that formula comes about?
Yes, teacher.
The mg is representing the force, because with the gravity, the force is actually the weight of the body. And then the distance is expressed as height, because whenever we are dealing with gravity, we are dealing with motion either vertically upwards or vertically downwards. So it's important that we note that one. We shall use it. Even in the example, they gave you the number you want us to do. The loss in energy will be actually the gravitational, the potential energy gained by the body. Aliyah, your hand is up.
What is the force of gravity on Mars?
What is the force of gravity? Come again.
On Mars.
On Mars.
What is the the gravitational force on Mars?
Very good. Now, since we have talked about weight, and we said weight is actually mass times acceleration due to gravity. One property we know about mass is that mass of the body does not change. Whether you die, your mass will remain the same. Whether you go to heaven, especially those who will go to hell will tell us whether the mass is changed or not. Those of us who will be in heaven give us calls.
Yes.
For example, who will tell us what is happening in hell? So, gravity, we see that now the factor determining someone's weight is actually the gravity, since the mass does not change. The mass remains the same wherever you go. But because the gravity changes with the places, so the weight you have when you are here on Earth may not be the weight you will have if you go to a different planet where the gravity is small. Okay? Why we have lakes on Earth is because the gravity is strong enough to keep pulling that water towards the center of the Earth. So that on our Earth, even if the lake is here, this is the lake, this water is not going to pour off into space. Why? there is a force that keeps pulling that water towards the center of the earth and does not allow it to escape. This is because the gravity here is very strong. But if you went with the water, for example, on the moon, and you put that water somewhere here, the gravity of the moon is very small that it cannot sustain holding this water here. What will happen? The water can pour off. And therefore, probably this explains why some other planets don't have water bodies on them. And even for those of you who watch TV, especially Discovery Channel, and leave alone those of you who watch cartoons. Now, some planets don't have water bodies. Probably this is one of the explanations that even if the water was there, there was no force to keep it on the planet. The gravity there is so minimal that to keep. If the gravity on Earth was very small, it means that even you yourself, you try to jump up like this, you will continue moving because there is no force that will pull you back to the Earth. But because on Earth, the gravity is very strong, it keeps pulling you back to the Earth. Some of you cannot even spend a second in space. You are too heavy. So you try to jump, the gravity pulls you back immediately back to the Earth. Chirabo has something to say, and then Condoleza. Chirabo first, Maimuna.
I'm just asking, what's that word after by?
Virtue.
The word energy possessed by a body by what?
By virtue of, I didn't realize that our body is small. Sorry about that. Energy possessed by a body by virtue of its position in the gravitational fields. We can continue now. We know how this formula came about. So we are saying the potential energy or the weight of a body can change depending on the gravitational force where that person is. And I was giving that examples of planet Mars, on the moon, and other planets. The gravity is not as strong as it is on Earth. And therefore, if on Earth, our gravity is 10 meters per second squared, and maybe this is on Earth, and maybe you go on the moon, and the gravity there is maybe 1.5 meters per second squared. Yet your mass as you, some of you as light as goats, and therefore your mass is only 30 kilograms. Supposing your mass is 30 kilograms, like whose mass is this? Let me check through. Annabelle, what is your mass? Supposing you are 30, it means that when you are on Earth, your weight is going to be your mass, which is 30 times the acceleration due to gravity, which is 10. And therefore you have 300 newtons. When the very person of 30 kilograms goes on the moon, where the acceleration due to gravity is 1.5, your weight there would be on the moon would be 30 because your mass does not change, but times the gravity at that point, 1.5, and probably this one will give you 45. You realize that you will appear heavy on Earth, but appear very light on the moon. Now, I was saying for those who watch Discovery Channel, leave alone Telemundo and Cartoon Network, there's a channel called Discovery Channel. When people are there, the way they walk is such that they should not lift their legs on the, because there's no gravity to pull back that leg. onto the surface. If you make a mistake and jump all the two legs off, you are going to continue because there's no force pulling you back to that planet. So you will enjoy swimming in space. Huh? There's a question here first. They're saying in many of the books we say at O level, I can just say that the gravity on Earth is always 10. That was just to make life simple. At O level, you have not done enough mathematics, and therefore, to help you not deal with fractions, we say it is 10. But in actual sense, it is 9.81. So for O level to simplify what, we round to the nearest whole number. So the 8 is rounded to the 9 to become 10. So at when you go to A level, there is nowhere you are going to use a gravity as 10. You will go to the actual value 9.81. We make it 10 to simplify life because many of you don't want to deal with fractions. So we round it to the nearest whole number. So in case you find it written as 9.8 or 9.81, please don't complain. Eh? It is the more accurate answer than the 10. But because we want to make life easy, we make it 10. It is easier for you to deal with 10. Right. In this, we have learned what we call potential energy. Quickly, the video told us about chemical energy. This is energy stored in fuels. Like you have firewood, the firewood can do work by cooking your food. Now it is stored the energy within it as chemical energy. We give an example of eating food. Food will give you the energy to move around. Some of you are moving around. The energy you are using, you are getting it from the food. Just go without food for one day and use it. If tomorrow you move around like that, you will have the energy. Food stores the energy in form of chemical energy. Fuels like petrol, like diesel, which enable the car to move, is stored within the fuel as chemical energy. Heat energy, this one comes from hot bodies. It can come from, if you heat fire, the fuels actually. They store the energy as chemical energy, but they don't use the energy as chemical energy. For example, when you eat the food, the chemical energy will change to potential energy, which will be in your body. And now when you are moving, you are using that energy, the potential energy within you. When the petrol is put in the car, it will change it's a chemical energy to mechanical energy that will enable the car to move. Later, we are going to talk about energy conservation and we see how energy transforms from one form to another. So, we have what we call geothermal. Geo is to do with rocks underground. Some rocks underground are very hot. You have heard of hot springs. Who boils that water? Sibia, your hand is up.
Teacher, under potential energy, I gave an answer of elastic energy, and you said you're going to talk about it under potential energy.
Very good. Supposing I have a table. This is a table. Actually, the Indian demonstrated it in a video, and he had a spring. And then he put some piece of wood here. Put some piece of wood near the spring. The challenge is our internet is still up and down. I don't know. Now I'm freezing. Let's see whether it can stabilize. Let's see whether I have some other.
We cannot see you.
Let me try to change my network. Here. Unstable. That's where we are heading.
Hi.
The one's sharing screen, you stop.
No.
Screen. Lina stops sharing screen. Let's quickly work up this one because I wasted a lot of time. So we are saying the Indian held a spring like this and then compressed the spring using this wood. When he released this wood, what happened? The spring pushed this wood and moved. That means when you compress the spring, it is actually now having energy. It's having the ability to do work. Release it. It uses energy to move this piece of wood. What it is having is a thing called potential energy. But this type of potential energy, since it is coming from the elasticity of the spring, we call it elastic potential energy. Just like this one, we talked about gravitational potential energy because it is coming out of gravity. Now this one, which is coming from the elasticity of the spring, we call it elastic potential energy. Am I now clear?
Yes.
Good. Continue. Your hand is up. Kirose.
Teacher, you weren't clear in the beginning.
I was
Teacher.
Saying that if we ask.
You weren't clear in the beginning.
Okay, let me finish up. Let me quickly go through. I said what you call elastic energy is to do with elasticity. Who knows a catapult?
Me.
For me.
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 A catapult. Me.
Or hitting birds, those who grew up from villages.
Me.
I will not mention the name. Now that catapult, when you put in the stone and you stretch, it is having the potential energy, it is having the ability to do work. Push that stone and it leaves and it goes at a very high speed. Now it has potential energy, but since this potential energy is to do with the elasticity of that rubber string, we say it is having elastic potential energy. The stone is not moving under the influence of gravity, it is moving under the influence of the elasticity of the spring. So the energy it is possessing will be called elastic potential energy. Whereas this body which is falling under the influence of gravity, it has gravitational potential. Proceed. Kinetic energy. Kinetic energy is energy possessed by a body in motion. I'll give 2 examples. Supposing someone is moving and he knocks you, he was walking and he knocks you, and another one knocks you when he was running. Where do you feel the biggest impact? Knocked by one who's walking or one who was running?
One who was running.
The one who was running.
The idea here is that the person who was running had a higher energy, had a higher ability to do work than one who's walking. They are all moving, but one has higher energy and another one has a lower energy. Now this energy due to something that is moving is what we call kinetic energy. We should realize in this case that kinetic energy will depend on how fast something is moving. A body which is moving with a slow speed will have a smaller kinetic energy. A body which is moving faster will have a bigger or larger kinetic energy. Are we together? Freezing again. Do we move on?
Why is it that different direction? Why is it that potential energy is gained? Why is it that when we have potential like can you get for us to receive
Mommy.
Network today. It's very funny. Let me try this one again. Anyone to remind me where I was? We are talking about kinetic energy. We said kinetic energy is energy by a body which is moving. Kinetic energy is energy possessed by a moving body. Now, by formula, what kinetic energy has been half mass times the speed with which the body is moving. If the body is moving with a velocity v, network again. Can you hear me?
Yes. Teacher, we can hear you, but
Yes, we can.
But your picture keeps on
We can
freezing.
hear you, but your picture keeps
you're
on
lagging.
freezing.
Can't see what you're doing.
Sure, we can hear, but you're lagging.
We can hear you.
She has gone to mute again. Oh,
Please
good.
repeat kinetic energy.
But you pause.
Teacher, please repeat.
She's going to mute again.
Please, you mute yourself.
Teacher, please repeat kinetic energy.
Yes, I have to repeat kinetic energy. But we are saying the kinetic energy is energy possessed by moving bodies. I gave you an example of if someone knocks you when he was walking and another.
Are you guys seeing teachers' actions?
No.
No.
Oh, thank God. I thought I was the only one.
So we are not seeing you.
I thought I was the only one not seeing his actions.
You guys, like, what's going on?
I don't know.
You be patient, you guys. He's
I
going
think
to
class
come
has
back.
ended. Class has
No,
ended.
it
I can
has,
assure what
it has not.
Please be patient. Teacher
Shanice
is going but
Banaye.
good, mute yourselves, please.
Who has understood? Yes,
Amina. Too serious.
Chichi Condolese. Yeah?
Ha, nothing.
You guys mute.
Okay, we're on WhatsApp. We're in a lesson.
Banaye, give me a break.
Condolence, my vids.
I'm going to send them after. We are in a lesson.
Quiet, quiet.
Class monitress.
Duh.
Who is one? The girl used to write names down.
She's missing this opportunity.
It's class over.
She cannot leave until the teacher says, bring the paper here. Then you.
Here, Amina, who was telling us to mute.
I have muted. That's my young brother, you guys. Family.
Banange, I mean, I keep quiet. Be sorry.
Guys, no need to be me.
Banange, I'm not mean. Sorry, I'm
Mute is about to come back.
Shirabo, don't use my name.
But the lesson is about.
Yes.
What has Condolence done, Banaye?
Just mute yourself.
You first mute yourself, then I'll mute myself.
I'll do it. First do it.
You
guys, that
You
lesson
guys,
has
teacher is back.
ended.
Where is he?
Thank you,
Serious.
teacher, for your kind services.
Shanice, be patient. The lesson hasn't ended.
She has the freedom to leave. That's why maybe she's saying bye-bye. Anyway, I don't know what's wrong with our network today.
It's bad.
It has been
Not that
long.
Tugabane.
Don't deny it. Tugabane.
Teacher, maybe you don't have enough bars for your Wi-Fi.
No Wi-Fi at Sosa's. Oh my God.
They have
Maybe
disconnected.
the connection. We haven't understood anything. Just end the lesson.
I want to finish. About kinetic energy, I want to do it very quickly. This time, give me some time.
Okay.
Energy possesses bodies which are moving. We have said this kinetic energy.
Yes.
Imagine
Teacher, you're gone again.
So you keep lagging.
Teacher, we can hear.
Tell me that you can hear. Teacher, it's okay. Yes, network is poor. There's
I
nothing
like
he
he
can
keeps lagging.
Teacher, where did you get the half from? Teacher, where did the half come from? And the squared?
It's a formula.
No, like how does it
It's a formula for kinetic energy. It's a formula.
Will you give me some time to explain?
Yeah, but you're lagging.
Mama teacher, you talk so long as we can hear.
Amina.
This what have you done to me?
Amina.
We are only seeing your face.
I'm seeing.
Is the lesson done?
Okay, are you?
No, it's not.
Amina.
You guys.
It's something I wanted to complete. I wanted to complete something.
And
So
you
that
guys mute.
Banai. Oh.
I'm going to mute everyone now. I think that this
This
is
teacher
not
is
there. Sibia say something?
Teacher, I was gonna tell you about everything, but fine.
All right. All right. What I wanted to explain is that since kinetic energy is possessed by moving bodies, it has a relation with the speed at which a body is moving. A body that will be moving faster will have more kinetic energy than one which is slow. And I said the formula is given by a half times the mass of the body times the velocity with which it is moving. So you realize that since mass does not change, but the velocity of the body can change. You can be walking and then you start running. You can be running, then you reduce the speed and you start jogging. Every something in your speed, you are even changing your kinetic energy. Because the formula says your mass and the velocity with which you are moving. So the higher the mass, the higher the velocity, higher Electric energy, the Muyindi told you about it, that is to do with electricity. Nuclear energy is to do with the nuclear substances. Nuclear substances, for those of you who can remember the periodic table. At the bottom of that periodic table is another partial table. It is a small table down, which is for what we call nuclear materials or nuclear radioactive materials. Those we shall talk more about those ones under modern physics. But we have some materials which decompose. On decomposing, they give out energy. That energy is called nuclear energy. So it is another form of energy. We'll talk about it more under modern physics. The rest, they are independent. They will come on their own in the course of physics. So I don't want to waste time on them. Our interest for now is kinetic energy and potential energy. This what state. Imagine a bar that is in space. So just imagine a body which is in space. Some people telling you to mute and you are refusing. A team say something. No? That one is I'm good, thank you. Yes, please. Bushra, say something.
Teacher, I didn't understand how you got the formula for kinetic energy.
I said we don't need, I think, to waste time on that because it is off our syllabus. For those of you who will do physics at A level, you come and we shall derive it. Here
Okay,
it will just confuse you for no reason. What we need is to know it and apply it. In A level, you will derive it, apply it, and also know it. Yes. Don't want to cause confusion here.
Thank you.
Let's be orderly. I've allowed people now to animate themselves, but let's be orderly. That's the challenge. Number up, say something. I'm going to say something. Okay, allow me to finish this. This is the body that is flying. First of all, it is above the ground. It is at some height, h. Meaning, this is h. This body has potential energy given by the mass of the bird times acceleration due to gravity times the height. Okay, it has potential energy, but it is also moving, maybe with a velocity v or with a speed v. then it means it also has what? Kinetic energy. It has kinetic energy, which is a half mass times V squared. Meaning that as the body is here, it has two forms of energy with it. It is above the ground, so it has potential energy. It is moving, then it has kinetic energy. Then we say these two energies combined. When we combine the kinetic energy and the potential energy, we come up with what we call mechanical
energy.
So when a body is in space, we can say it is having a mechanical energy. To summarize the issue of being with potential and then kinetic. Now, after this one, I just want us to go. I want us to quickly look at energy conservation law. Energy conservation law. Anyone with an idea about energy conservation law?
Teacher, I have an idea. The energy conservation law says that energy can neither be created nor destroyed, but can be transformed from one form to another.
Very good. That it says that energy can neither be created nor destroyed, but transforms from one form to another. When you eat the food, you have taken in that chemical energy. The energy is not just wasted, but it is converted into the mechanical energy which you use to move, which you use to do some other work, and the remaining is stored within you as again chemical energy. So that when you die, that energy again transforms to another form of chemical energy, and you become a fertilizer. You know that one. So there is wastage of energy when they bury. You are doing us a disservice. In fact, when you decompose, you're supposed to have to become fertilizer. Now, if you planted some matoke on your grave, that matoke should grow very well because it is getting fertilizers from you. The energy you had, the chemical energy you had, you think it is wasted? No. It is transformed to another form of energy that will enable the plant to grow very well. Now, when the plant grows, it again provides chemical energy to another person. So the idea is that, are you seeing a transformation of energy? There is nowhere we are wasting the energy. It just keeps changing from one form to another. If you don't become fertilizer, you become fossils. Fossils is the source of petroleum. Things that decompose long time ago, they are the ones which become petroleum. Like Uganda, you say Uganda, we have petroleum, we have petroleum. That petroleum can even be your ancestors.
Yeah.
Teacher, my hand is up.
Condoleezza, say something quickly. We are supposed to have.
Teachers asking, like you've said that potential energy plus kinetic energy is equal to mechanical energy. So what's the method like for mechanical energy? Like, is there a method, or it's just like that?
Okay. So it's like saying A Muganda male and a Muganda female gives us the Buganda kingdom or the Buganda clan, the Buganda tribe. Is the tribe having a formula? The mechanical energy is just like a general name of combining kinetic energy and potential energy. Itself is not specific that it has a formula, no. Just that when you get the formula of potential for kinetic energy, when you calculate and add the two, what you have is neither potential energy nor kinetic energy, but it is mechanical energy. You just add, get the potential energy, get the kinetic energy independently, add the mechanical energy. I want to end with this one. Yeah. According to this number, I've given an example of a person that will eat the food which has chemical energy. Chemical energy transforms into mechanical energy in your body that will help you to work, help you to move, and so on. When you die, that mechanical energy within you will again change to chemical energy or chemical energy actually, in form of either fossils, which will become petrol or diesel, and the diesel will again be reused. So the energy was not wasted, just transformed. Another example is that when I drop this chalk, we are saying when it is in space, it has potential energy. But when I drop it and it lands on the ground, one, it is going to have some mechanical impact. It can drill some hole on the ground if the ground is soft. It will produce sound. If they were hard rocks and they knock each other, they can produce some light and even some heat. Meaning the potential energy this chalk had in space has not been wasted. It has just transformed into sound, light, heat, and so on. That's what we are meaning with energy transformation, and the energy will not be wasted. It will just be changed from one form to another. In the same way, if I release a ball, there's a ball here, and it is at a height of maybe 5 meters. When I release it, when it is here, it has potential energy. This potential energy, we say, is given by mass and acceleration due to gravity times the height. If we can use the other example of yours, the ball had which mass? 1 kilogram. So it has 1 kilogram times acceleration due to gravity, which is 10, times the height, which is 1. 5. Overall, it has of energy. That's the potential energy it has here. So when it is released and dropped on the ground, as it is coming, as it is moving, it is having kinetic energy because it is moving. But you also realize that potential energy is reducing because the potential energy depends on how far it is from the ground. To 0. When it is on the ground, the height is 0. Is it having any potential energy anymore? From the formula, H has become 0. Anything times 0 is 0. Meaning it has lost that potential energy. Which energy has it lost? The 50 which it had. Answer to our question. Do you have the answer to the question we started with? When it was 5 meters above the ground, it had potential.
Teacher, the answer was supposed to be 30. That's what
And now we are, probably you didn't read the complete question. You didn't complete
that's how it is. That's how it is.
So teacher, the potential energy is the energy lost.
When it goes to the ground and it is completely on the ground, it is now going to have, you will have lost. But by energy conservation, we told you this energy, yes, we are looking at it as a loss, but it has actually changed into another form of energy. Because, for example, this ball is not going to just be on the ground and it remains there. Want it to roll? It is likely to roll. When it is rolling, it is having kinetic energy because it is still moving. When it hits the ground, it can make sound. That's another format. So the potential energy has changed to sound as well as the kinetic energy because it continues to roll. Is it making sense? Now, at many times we use that example, we use energy conservation law to do such numbers. For example, I can say, this is the ground. I'm going to throw a ball upwards. And then I know that it can't remain there. Not so. So supposing I throw it, this ball, with a velocity of maybe 5 meters per second. It means that when the ball is just starting the motion, it has kinetic energy given by a half mass times velocity squared. Supposing this ball has a mass of 1 kilogram, then it has a kinetic energy of a half times 1 times 5 squared. Does it give 12.2, 12.5 joules? It has an energy of 12.5 joules. Now, when it starts moving up, imagine it has reached here. It is still moving, so it has some kinetic energy in it, but it is again some height above the ground. So it has again potential energy. So when it is here, it has both potential energy and kinetic energy. Why? Kinetic energy because it is moving. Potential energy because it is some height above the ground. But as it is moving up, the kinetic energy will go on becoming smaller and smaller. You know that when you throw something up, the speed will go on reducing until it becomes 0 when the ball cannot continue upwards, but instead it will start dropping downwards. So as the ball is moving up, its velocity is reducing, meaning its kinetic energy is reducing. But what is happening to the potential energy? As the velocity is reducing, its height is increasing. So you are having potential energy increasing as the kinetic energy is reducing until you reach a point at the maximum where temporarily the ball is no longer moving. It is neither moving upwards, neither has it started the downward motion. At that point, the kinetic energy is 0 because there is no motion anymore. But the potential energy is now maximum because the ball is at the highest possible height above the ground. H is maximum, it can't go beyond that. Then we say it has maximum potential energy. At this point, potential energy is maximum, while kinetic energy becomes 0. Because at that point, the ball is no longer moving upwards, neither has it started moving downwards. So we say all the potential energy, all the kinetic energy has changed into potential energy. Are we together?
Yeah.
So all
Yes.
12.5 has become potential energy. So we can say from the formula potential energy is equal to mass times gravity times height. Then 12.5 has become the mass, which was 1 kilogram. Acceleration due to gravity is 10, and the height is h. So this method, this formula, can help us to find the maximum height the ball reached. You realize that only h is the unknown here, and therefore we can find it. So when we divide it through by 10, we can realize that h is equal to 1.25 meters. It means this ball went up to 1.25 meters, then it had to come back. we use energy conservation law. A team is the last question we are going to have. Probably we shall have more examples later in another lesson.
Teacher, that part I have understood, but there is that question that Mr. Pendaula had given us. He said our answer was 50. But then, like,
electricity.
I hope that question was, I hope it was not a subsection.
Teacher, no.
Read the
It
question
was
again.
a number of its own.
Someone read it
Yes,
to me
it was a
again.
number of it.
Hold on,
A ball
someone.
with 1 kg bounces off the ground to a height of 5 meters. Find the energy loss. And the answer was meant to be 30 joules.
Yeah, and even though you work it out, there's no way you get 30.
Yes, unless maybe through PE, which is equal to mg times height, which is equal to mass times gravity times height. Then you get 50.
Oh, by the way. Yeah.
Probably you looked at it in a, was it in a text?
No, like we took a screenshot and the screenshot, like it had answers.
Yes, I think you should talk to Mr. I don't
Should have been an should have been an error. Now, sometimes where we talk about energy loss, yes, is, for example, if I release the ball, if I had the ball over here, now this is the ground, I'm throwing a ball from here, from this height. I'm calling it H. When it lands on the ground and it bounces off, does it go back to the exact height where it came from? No.
No.
It comes and stops somewhere here like this. Huh? The process is like that until when it becomes maybe. So it means that at least potential energy here, when it is released, once it reaches the ground, we would say all the potential energy has changed into kinetic energy. So the kinetic energy here should be equal to the potential energy here, which is not true. If it was true, this ball would go back to the same height. But why does it reduce? When it falls on the ground, it gives out sound. That sound is some energy which it had. So that energy has been lost in the form of sound. And therefore the body, by the time it goes back, it is no longer having the exact sound, the exact energy it had earlier. And therefore, you can find the kinetic, the potential energy at this point, and you find the kinetic energy here. You find the new potential energy. So the energy here minus the energy here gives us the energy lost. But we said it is just being lost in the form of other forms of energy. That is either sound and light and so on.
Then it's according to what you are saying. Can I be able to find
kinetic loss? Yes, it is possible. You can find kinetic loss because the kinetic energy here will not be the kinetic energy here. It won't be the kinetic energy here. You see that the weight is going on reducing. So some energy is being lost in form of sound and other things. So you can have, we shall have more examples, but I think that number had issues. The answer may have not been picked very well. It should have been 50. Because the energy loss would be the loss in potential energy. I want to end here for now. The network did us a disservice. We didn't really have we didn't have enough time to elaborate everything and try out numbers. But probably next time, whether with me or with Mr. Sendaula, we will continue and do some examples of energy.
Thank you, teacher, for teaching us. Your participants are highly appreciated. May God bless.
Thank you, teacher, for
Bye.
teaching us. Yeah. The spirit.
Bye.
See you tomorrow.
Yeah.